This is section 2.3, and this is the second video in this function. Today we're going to continue talking about our polynomials, and now today we're going to focus on finding the zeros, so finding the x-intercepts. It's going to help us decide a little bit better what's going on in the middle of our graph. Remember, yesterday we talked about the end behaviors. Today we're going to start looking at the middle. So, the first thing is that we need to talk about how to find the zeros. Now, zeros, remember, are a fancy way to say roots, solutions, x-intercepts. Those all mean the same thing. And in order to find zeros, we know that it's when our f of x equals 0, or when our equation equals 0. So, here's our first example here. And we want to know what the zeros are for this polynomial. Now, this doesn't look like our normal polynomial. If I multiplied all that together, though, it would. Now, the nice thing about this polynomial is it's already given to us in factored form. So we can use the zero product property really easily and find our zeros. Remember, we're going to place the f of x with a 0 and solve. Now, in order to do that with the zero product property, we would just take each of these pieces and set them equal to 0. Now remember, x minus 7 squared is just like saying there's two x minus 7s. And really, we don't have to look at one of them because we know we'll just get the same answer twice. So we get 3 different zeros, one at 4, one at -3, and one at +7. And these would be our 3 zeros, or our 3 roots of this equation. Now, because the -7 actually had 2 answers, in a little while we'll talk about what that means and what that's going to do to the graph. Take a look at this next example, and what do you notice? I'd say it's not in factored form, so it's not so easy right now to find the zeros. I can make the f of x equal to 0 just like before. But now I have to factor this. This is nice because the leading coefficient here is 1. There's a 1 in front of the x squared. So remember the shortcut here, I'm just looking for 2 things that multiply to 6 and add to 5. And they're going to be 3 and 2. So that means our factors here are x plus 3 and x plus 2. This is pretty easy now to solve with the zero product property. We know we get 2 solutions when I set each of those factors equal to 0. Our 2 answers become -3 and -2. And so those are the 2 zeros for this polynomial. Let's look at another one. Find the zeros. This equation looks a lot different. I have 3 pieces with x's, a piece without, and a highest exponent being 3 instead of 2. This isn't a normal quadratic. I can't factor this with our diamond and rectangles. So, this is a special case. I can actually factor this one using what we call factoring by grouping. I'm going to start by grouping together the first 2 pieces here. Now those 2 pieces have an x squared in common, so I'm going to pull that out in front. When I pull that out in front of the first piece, I'm left with an x. When I pull it out of the second piece, I'm left with a 3. When I group together the second 2 pieces, I notice they both have a negative in common, so let's pull out that negative. When I do that, I'm left with an x plus 3. Now, I have these 2x plus 3's here in common. So I'm going to take those and I'm going to pull those out in front of everything. When I do that, the leftovers here, it's like dividing by them. They're going to go away. On the first piece, I'm left with an x squared. And in the second piece, I'm not left with anything, but remember, if I was to multiply that back in, I'm going to have to put a 1 there, so it's a -1. And that would be the factors here. Now, it's not quite factored all the way. X squared minus 1 factors a little bit further. It's the difference of two squares. So that's the x plus 1, x minus 1. The zero product property now would give us three roots, or three solutions, -3, +1, and -1. So in this case, again, we use what we call factoring by grouping. Go ahead, pause your video and see if you can factor this one with grouping. Now, hopefully, when you factored this one by grouping, you grouped together the first two terms and pulled out the x squared, and you were left with x plus 5. And when you did that with the second piece and pulled out the -9, you were left with x plus 5. Now, the two pieces you're left with, these two pieces here, the x plus 5s, they have to be the same. If they're not the same, then this factoring by grouping doesn't work. We want them to be the same so that we can pull them out into the front. Notice when we pull them out into the front, there's only one of them there because we're just taking it out of both pieces. If I were to distribute that back in, you'd get the previous step. Okay, so now if we want to continue solving here, we need to factor our x squared minus 9 a little further. And again, this is another difference of two squares. So it factors into x plus 3 and x minus 3. And now we can see our final zeros, -5, -3, and 3. Let's look at one more example before we go on to the next objective. Again, find the zeros. So we need to start by factoring. In this case, grouping is not really going to help me. I only have 3 pieces. But each piece, it looks like, has a common factor of an x squared. Let's go ahead and pull that x squared out in front. And I'm actually going to take the negative with it. So let's say we have -x squared. Now when I take a -x squared out of -x to the 4th, I'm going to be left with +x squared. Then I'm going to be left with -4x, and lastly a +4. Notice that all the signs switched because I took the negative out with the x squared. The nice thing is inside my parentheses, I just have a basic quadratic here, and I can factor that with my diamond. I'm looking for two things to multiply to +4, but add to -4. And it looks like they'll both be -2 and -2. So I get 2 of the same factor here. I'm going to get an x minus 2 twice. Remember, that's not that big of a deal because it just means that we're going to get the same solution twice, but we'll only write it once. The zero product property says we have to set all these pieces equal to 0. Now, a common mistake is going to be to forget that x squared in the front. The nice thing, though, is it's easy. That -x squared just gives me an x as 0. The other one is going to be +2. And so I have 2 solutions here, 0 and 2. Now, remember we said that this x minus 2 has 2 factors of it? It could be written as x minus 2 squared. This squared makes this what we call a double root because it has the same solution twice. Let's talk about what that's going to mean to our graph. Now, that double root means it has what we call a multiplicity of 2. Multiplicity is just how many factors of the 0 are there. So are there 2 of those zeros, 3 of them, 4 of them? In order to decide that, you're really going to look at that exponent outside the parentheses. If it's an even number, like 2 or 4 or 6, it means the graph is going to touch that 0 and then turn around. You could think of it as a bouncing off that 0. So if it's an even number, at that 0, the graph is going to touch but bounce off. So it's not going to cross the x-axis. It could also be coming from underneath, so it could also go this way and touch and bounce off. We don't know right now which way it's coming from, but we do know that if the multiplicity of that 0 is even, it's going to touch and bounce off. If that multiplicity is odd, for example 1, meaning there's no exponent, or 3 or 5, then the graph will cross there. So if this is my 0 now, with an odd multiplicity, the graph is going to be coming towards it, and it's going to cross through and go below. Or it could be coming from below and cross through and go up. So now the number of factors of that 0 are going to help us decide what's going on at that spot. So let's just take a look here. We want to find the zeros of this function, and then we want to know what's going to happen there. The nice thing is we're already in factored form. So we just need to make the y equal to 0 and use our zero product property. So we'll have x plus 1 equals 0 and 2x minus 3 equals 0. When I solve the first one, x equals negative 1. Now, we only have one factor of that because it doesn't have an exponent. The exponent is 1. So that means at x equals negative 1, the graph is going to cross there. It's going to cross over the x-axis. Over on this other one, we're going to have to add 3 to both sides and divide by 2. So now we have 1.5 as our root, which is okay. We can have a decimal for a root. Its multiplicity is 2. This is an even number. That means that x equals 1.5, the graph is going to bounce off the axis. It's not going to cross. So now we know what's happening a little bit in the x-intercepts. We also know that we can find out the end behavior. Once we find the end behavior and what's happening at the x-intercepts, in our next video, we're going to put that all together and be able to graph these polynomial functions without using our graphing calculator. This, though, is where we're going to end today. You can try this one question and bring your answers to class tomorrow.